Wi-Fi signals travel much further because of the higher transmit powers that we have as Wi-Fi. So in that case, Wi-Fi will have a significant advantage over some of these other locationing technologies because of the higher powers that we have.
Today on The Signal, we hear from Qualcomm about Wi-Fi location tracking, how it works, and how it will be used. Welcome back to The Signal. I'm Martha DeGrasse here for Wi-Fi Alliance, and we are delighted to welcome back Rolf de Vegt. He is VP Technical Standards for Qualcomm. Nice to have you back on The Signal, Rolf.
Thank you for having me back.
So today we're going to be talking about Wi-Fi location. So I think you're a great person to explain what that is and why it's important.
Okay, let me talk about that. It's a technology that's been around for quite some time. The basics of it are that Wi-Fi location or Wi-Fi fine timing measurement allows you to estimate the distance between two devices. So, for example, an access point and a client or two clients.
Okay.
You can do a fairly accurate measurement of a distance between two devices by measuring the time that the signal travels from one device to another. So we are looking at the speed of light, measuring the speed of light. So, you need to do very accurate measurements. And that's a technology that's been evolving since about 15 years and became part of a standard in IEEE and a Wi-Fi Alliance certification program. And it's slowly proliferating into the marketplace.
So I can think of a lot of possible commercial applications for this. What are some of the big ones that are emerging?
The real obvious one that people can easily relate to is for indoor location. Like you're using your phone when you navigate outdoors, it's GPS,
so
satellite-based.
finding your way around the mall.
Finding your way around the mall. Outdoor, it would be typically powered by satellite GPS. But then for indoors, that doesn't really work. And then, so for indoor, you could use Wi-Fi location that by triangulating the distance measurements from different access points that your phone sees, that would be an example of. But there are numerous other examples. It would be for asset tracking. So in healthcare, for example, trying to locate a particular piece of equipment.
As fast as you possibly can. Yeah,
yes, as fast as you need it. Asset tracking in all kind of environments, or for in warehousing, locating particular devices. An emerging type of an area is in the area of access control. When you get with your device, you get close to a door.
Oh, you don't need a key card.
Yeah, exactly.
Nice.
Those kind of applications.
And even a hotel could put it on your phone when you check in.
Yes,
that'd
you
be
could.
nice.
Sorry, if you get closer to. But you can also think, maybe a little bit more forward-looking. People in smart homes only turning on lighting when you have a presence in a certain room.
Sure.
Those kind of areas, especially we're getting into these energy crunched environments where you can start to think about, okay, once you can fairly accurately estimate where a person with his or her device is, change the ambience around it. That would be another example.
Or what about in an emergency situation when the first responders get into a large building and they need to find the person they're looking for?
Yeah, that's actually one of the newer application areas in the United States. We have an E911 indoor location mandate coming up pretty soon. And Wi-Fi location may be one of the enabling technologies for that. Emergency responders need to know where they can locate. And thus far, there was never a mandate for indoor locationing, but that is coming soon. So that would be another one. Another use case would be geofencing. You're in a park and you have your kids around you. If they get outside a certain boundary of view, you get some alert. That would be another example of.
That sounds like a good one too. Okay, and how does Wi-Fi compare to other locationing technologies like ultra-wideband?
What's happening in the industry is that the category of device-to-device ranging or distance measurement is becoming much more pronounced. So there are other technologies like ultra-wideband or even Bluetooth SIG is trying to come up with a technology that does better estimation. Those technologies, compare that to Wi-Fi. Wi-Fi signals travel much further because of the higher transmit powers that we have as Wi-Fi. So in that case, Wi-Fi will have a significant advantage over some of these other locationing technologies because of the higher powers that we have. So for example, we did a set of measurements a few months ago at Qualcomm to see how far away we could do this kind of distance measurement. Outdoors, it would be over 200 meters. We could do fairly accurate, less than 1 meter for one set of measurements, accurate measurement at a 200-meter range.
Okay, so Wi-Fi really does have a benefit over other technologies.
That will be one of them, right? So the distance will be one of them. The other key benefit is that it comes with your Wi-Fi radio. Every device has Wi-Fi today. Every laptop, mobile phone, lots of devices. If you use some of the other approaches, you will have to add a radio just for that single purpose. With Wi-Fi, it comes with the Wi-Fi that you already have. So there is no incremental cost of adding this technology and so that's another significant benefit. So there's the range benefit, there's the benefit of having it already, because you used Wi-Fi as your, normal networking technology. Yeah, and then in terms of accuracy, if you talk about how to get to accurate Wi-Fi ranging, the industry sometimes has done itself a little bit of a disservice because very engineering focused, we quote the measurement of one single measurement, where we say, okay, one single estimate between, say, an AP and a client.
Okay.
That's what we quote to the outside world.
Okay.
And that's when you get to range estimates of around a meter, accuracy roughly. However, there are approaches out there why just by doing multiple measurement in a very rapid-fire fashion, you can, and then average across those multiple measurements, your accuracy goes up dramatically. So say if you get to a meter accuracy by just doing one measurement, if you do that 32 times, you get to less than 20 centimeter. So that's a simple approach like averaging, and you can do 32 measurements in less than a second.
Really?
And then you get into accuracy levels which are very comparable to other technologies that are being out there.
Okay. And how will Wi-Fi 7 impact all this?
The benefit of Wi-Fi 7 will be that it's really a technology fit for 6 gigahertz operation, right? And 6 gigahertz, in some markets like the US and Brazil and Korea, we will have 1.2 gigahertz of spectrum. Allows you to get to much wider channel usage.
Yeah.
And one of the key drivers for accuracy in distant measurements is the amount of spectrum you can use, the bandwidth you can use. So if you get, in a typical Wi-Fi, say 40 megahertz channel, if you go to a wider channel of 80 megahertz, your accuracy improves dramatically. If you go to 160 megahertz wide channels, it even improves more. Wi-Fi 7 brings a new mode called 320 megahertz wide channels. So that again doubles the bandwidth that you have available to do these measurements. And that's one of the key enhancements that Wi-Fi 7 will bring to this technology space as well. In the IEEE, we're going to do a very focused project to standardize that, because it's not been standardized yet. 320 megahertz operation. It's going to be a new project kicking off in a few months, and the moniker is going to be 802.11bk. Called the Burger King approach, the Burger King
now
standard.
I can remember it.
Yes, so BK standard.
It's a Whopper.
That's exactly. It's going to be a Whopper for indoor locationing. But if you think about it, so 320 megahertz wide channel. One of the other technologies is ultra wideband. It's ultra wide, but that's 500 megahertz. So 320 to 500 megahertz. That's not that far apart. So we will have 320 megahertz wide channel to do this with Wi-Fi 7. To do this accurate measurements. Then we have the higher transmit powers of Wi-Fi, the longer range, the fact that it comes with your run-of-the-mill Wi-Fi anyway. So that really expands the advantages that Wi-Fi has in this space.
Okay, yeah, you make that very understandable. So thanks for explaining that. Okay, let's step back and talk about Wi-Fi location in the context of Qualcomm. And obviously, you're involved in all kinds of different things. So can you sort of explain how this fits into your overall portfolio?
Yeah, this technology has been in our portfolio starting since 2009. That's when we first introduced this time-of-flight measurement technology. We call it RTT, round-trip timing technology, both on the access point side and on the client side. And then in every subsequent generation of our chipset has been part of our core capabilities that we've delivered to the marketplace. So it's an integral part of our offering and continues to be. So we're really trying to get the industry engaged to step up on that, and we see it as a very important use case enabler going forward.
Okay, all right. And I think you recently introduced a white paper on location.
Yes, actually, yeah, it was a year ago.
Okay, not that recent.
But it's still very very current in terms of what we lay out there, and I would highly encourage people to have a look at it because it's we try to make it understandable for a very general purpose audience.
All right, we'll try to get that into the show notes. Are there any key takeaways that you want to highlight here?
In the paper, we explain, what the performance drivers are for accurate locationing, accurate ranging.
Okay.
In it, we also make the point that I already, discussed, which is this averaging. The fact that by averaging over multiple measurements, you can get to very accurate distance estimations. For this technology to really flourish, you will need to have applications that actually use these. What we as Qualcomm, as a radio delivery, is just a set of distance measurements that we would pass up to an application layer, and then an application would have to build on that. For application developers, there's the benefit that once they have these sets of measurements, they can do even way more sophisticated things like applying location tracking algorithms to it to further enhance the accuracy of predicting, for example, in the indoor locationing case, by applying location tracking algorithms and knowing which direction a person is moving, you can really further increase the accuracy of pinpointing where a person or a phone or a device is at some point in time.
Well, and I'm guessing that you work pretty closely with a lot of application developers. Qualcomm sort of has a history of doing that.
Yes, in this market, there is a key dependency on the device side, on the operating systems. So, Android has been very very proactive in this space.
I see.
Has made a whole set of developer tools available, sample applications in the Play Store that developers can download and see how they can use the technology.
Okay.
And and that's a player that we work very closely with. Yeah.
Okay. So Android's leading at this point as far as the applications. Okay, that's good to know. So you've talked about quite a few use cases indoor as well as one outdoor use case. Are there any other use cases you want to highlight before we finish?
When we started this whole journey, there was one use case I'd like to talk about, and it's a bit of tongue-in-cheek use case, which is more consumer-focused, but ordering some beers in a crowded bar. When you want to order some beers and the bar is full and you have to line up, but you don't want to spend all your time lining up to get your beers. So wouldn't it be great if the bar had some kind of an app? You would order the beers, and then some bartender would just find you in the crowd. You can move around, but they will be able just to pinpoint and find you and provide you your order. That would be one kind of application.
That sounds good.
But more seriously, just fairly recently, a very interesting set of usages is coming up in the context of a 6 gigahertz operation, and it's somewhat regulatory driven. For 6 gigahertz, there is a particular power class called standard power, and in order to operate in that particular power class, which has certain benefits in terms of range and throughput and so on, the access point needs to communicate its geographic location to some kind of a server, an automated frequency coordination server. And there are some rules defined on how an access point can specify its location. And if it's an outdoor AP, typically they would use a GPS locator to automatically then say, oh, this is my exact location. And so then the automated frequency coordination system can tell that AP which frequency they can use at that particular location. However, when you're indoor and you cannot have a GPS fix, or for other reasons, access points cannot have a GPS technology embedded, there is Wi-Fi ranging allows you to effectively pinpoint the location of an access point indoor by triangulating between known fixed locations of access points and then the access points that are indoors that do not have the GPS capability.
Okay.
And that's another application of ranging technology. It's being deployed already in the field. We also see it showing up in regulatory applications.
Is it in the U.S. or Europe? Or
in
where?
the U.S., yeah. This is, as of yet, it is driven by U.S. and Canadian regulations.
Okay.
But we expect that other geographies would pick this up as well. But it's novel in the sense that thus far, in the case of Wi-Fi location, we've been talking about access point to client or client to client. But now it's access point to access point ranging. So that's the...
Opens up a lot of new possibilities.
Yes, yeah.
Rolf de Vegt, VP Technical Standards at Qualcomm. It was great to have you back here on The Signal. Thanks for making the time.
Thank you, Martha.
And that is our show. You can check the show notes for links to some of the resources we discussed today. And for all things Wi-Fi, visit y-fi.org, wi-fi.org. That's the Wi-Fi Alliance. You can also find links to past episodes of this podcast there. Our podcast is also available on Spotify, Google, and Amazon. Thank you so much for listening to The Signal. Please join us next time.